So we'll get started and talk a little bit about the infrastructure necessary to go build 100 million wallets. We've heard a lot about blockchains. We've heard a lot about the different capabilities in the infrastructure of Bitcoin. One of the great challenges is how do we actually secure and make it easy to use? And I think these are one of the key tools to make that happen. So I want to start with the core objective of what we're trying to do and how we're applying these technologies. This is about really delighting the customer with the experience that they have around their Bitcoin experience. How do we have great design, simple and intuitive use, automation, and great quality? And all these are interesting terms. You'll notice that we don't use a lot of security or privacy terms within this. It's about providing the user with the experience that they expect. Reliability is a great way to think of this. When you want to do a transaction, you expect that you push the button and the transaction happens, and that something else doesn't happen. That's really a surprise. And when we're doing transactions, we don't want surprises. And we want the technology to be there when we need it, on the device we need it. Whether it's your phone, your PC, your tablet, your television set, we have a multitude of devices. We live complicated lives. Humans are complicated things. And we want to do transactions when we need to do the transaction. We don't have to go find other stuff to do it. I want to talk a little bit about instructions. So you've heard about the blockchain. And in the context of the blockchain, we've heard about it from many people during the course of today. What you send to a miner is what gets put in the blockchain. And so the instructions to the mining infrastructure is really important because the amount that you're going to spend, the address, and ultimately the user's intent to do that transaction are collected and sent to the mining infrastructure to be part of forming the transactions that form into the chain. If we send the wrong amount, the blockchain will do an absolutely fantastic job of storing the wrong amount for all time. And so it's important that the quality of the instruction that we send actually contains the information that I intended to send for the transaction that I do. And so I think quality is a great way to think about how we deliver to the blockchain an instruction that meets what I intend to happen. And over time, we'll continue to improve the technologies to improve the quality of instructions on the blockchain. You've heard some about distributed applications. And distributed applications are fantastic. It's a peer-to-peer network. But distributed applications rely on the fact that an endpoint device is going to present or is going to collect information. And it's really critical that those endpoints have some of the core characteristics that we need in computing. We need integrity and security and confidentiality and privacy, and we need really strong identity. Why? Because otherwise I can insert a rogue endpoint into the network. And so in reality, we'd really like some infrastructure that helps us to secure the peers. And so a common mechanism in a distributed application, simple concepts like just tamper-resistant identity would be an incredibly powerful tool in the distributed application network basis. So devices are the interface to Bitcoin. It is possible, because it is ultimately a cryptographic protocol, to, with a pen and paper, construct a Bitcoin transaction. We should sort of have it as an exercise someday to realize that it takes you a little while to do all the math necessary to actually sign the event, but it's all basic math that any one of us could do. In reality, we don't. We trust devices to do the transaction for us. Whether it's an offline device from cold storage or it's an online device, whether it's just a transaction that we send up to a server and trust a server to do it, or something we have. But the devices ultimately are our interface into the blockchain. And it's important that the devices that we want to interface into the blockchain do the things we want them to do. The classic attack here is malware. And Bitcoin is really, really, really early on in its process and really doesn't have very much money attached to the network yet, so the hacks are just getting warmed up. As we get farther down the path and it becomes possible not to just spend a few $billions, but you can go steal more than that, then the infrastructure required to secure the blockchain is going to need much more substance underneath it. So let me talk about what I think we need in order to build a device wallet. And I've put up a very abstract picture here and intentionally. There's an Essence wallet software. Earlier on today we heard about dozens of different applications for Bitcoin, and there will be custom wallets for those applications. You'll have a different wallet for signing. You'll have a different wallet for different colored coin transactions. You might have invisible wallets on your platform like in MadeSafe where they'd be embedded within the application. Maybe you don't even see them. So there's lots of different types of wallet software that will be out there. What we're proposing doing is providing an interface to the hardware that is standardized within the platforms that you already have. And I'll talk about that technology in a second. But inside that are a number of core capabilities. The first is secure display. So why is secure display important? I like to use the example that if anybody's gone to France to have lunch or have a coffee, you sit at the table, you pay with your credit card, they bring the terminal to your table, you put your smart card into the terminal, and the reason that they bring a terminal to your table is so that you can confirm the amount that you're being charged. And it's shown on an actually tamper-resistant screen. And so when you confirm that, you as the consumer have actually been able to view what you're going to be charged. It's not like a Visa transaction where somebody goes in the back room and then adds your tip later on. Secure input is important. Secure input is how you collect the user's intent. So the user's intent is, I put a PIN number in. Excellent. So that probably proved I was there. So now I know the amount that I was being charged. I've put a PIN number in to confirm the user's intent. But ultimately, I need to protect the private keys. It's great that we have client-side PC wallets. Just understand those keys are highly vulnerable. Anybody with a memory attack can go steal those keys. Because what happens with a key? When you take a key, no matter how much work we do in software, and there's some incredible technology out there for obfuscation of keys, we take that key and we stuff it all the way down into the memory stack, into a processor, your Intel processor, and then it has to do the math to sign the transaction. And in order to do the math to sign the transaction, it has to be a key that you can read in the clear. And there are a number of attacks. The hardware, the encryption industry has been suffering from these attacks for years. Full disk encryption is a great example, and if you want to read about the Evil Maid attack is a great set of use cases around stealing keys out of memory, even from a drive or from a computer that's been turned off. And so the last thing you did, and then you turned your computer off, you can actually go extract the keys. And if anybody's been to some of the really fun security conferences, you haven't really done anything until you see the guys steal the keys from an iPhone from a meter away with an antenna. So they actually read the noise that comes out of the chip and have been able to extract information out of your iPhone from about this far away, which is a really interesting demonstration. Now, is it practical for stealing keys? Probably not, but it's a really interesting demonstration. And then ultimately, how do I know that the environment that I've built to protect these keys has the capabilities that it claims to have? So attestation is a very important piece, and we'll talk some more about that, but the concepts of peer attestation we think is a really interesting new idea in this space. But all of this sits on a foundation, we believe, of the trusted computing and trusted execution standards in the world. So let's talk a little bit about those. So trusted platform modules is something you probably haven't heard of, but it's in 1 billion PCs. So there's a hardware security chip on the motherboard of your PC that provides the tools to protect and store authentication and private key credentials. And it's available for anybody to use. It has the same security and quality of a SIM chip, and yet it provides a general purpose capability to any to the platform for any application. In addition to trusted platform modules, and so where does this come from? This is an industry standards body. It was started back in the early 2000s timeframe. It's made up of over 150 different companies, all the major manufacturers of devices, most of the major networking manufacturers, companies like Google's are members of the Trusted Computing Group, and they've set standards for a common mechanism and a common interface and a common design, and chips are made by now at least a half a dozen different manufacturers around the world. They're certified by lots of different bodies, so you can buy German chips certified in the UK, deployed in Taiwan. So it really is a global infrastructure for trust. On the heels of trusted platform modules comes the second piece of infrastructure. This is really the second wave of capability within the trusted computing space, which is trusted execution. And trusted execution exists today in two fundamental platforms. One is the ARM platform, and certainly that's what you find in all of your smartphones, tablets. It's very broadly deployed in the mobile space, and on Intel's TXT technology. They're both different implementations, but if you take them apart, they're very roughly the same in the actual details of how it works. What trusted execution provides is the ability to load a program, run a program, but that program is signed and encrypted code. And so what you have is the ability to execute code that runs in a hardware isolated section of the processor. So inside your processor, normally I have all my instructions that go up and down in the processor. What they've done is they've put a second processing capability in the platform that doesn't run your Windows OS or your Android OS. It runs its own, and it's completely isolated when it executes. So it is a software tamper-proof environment. You'd actually have to break the hardware in order to get inside the code. So I have this new capability in the platform I can do all sorts of fun things with, and it has access to the full horsepower of the processor. So it's quite interesting what's possible in these environments. So these are the devices you have. Trusted execution today exists on over 200 million ARM devices, support a set of applications called Trustonic, which is a joint venture between Gemalto, G&D, and ARM. Gemalto and G&D are the guys who make all your SIM chips. They probably don't make all of them, but they're close to all of them. And they're supported on Android, AMD. A good example is if anybody has a, excuse me, a Samsung Galaxy 5S phone, it has Trustonic capabilities in that phone. There are 250 million Intel TXT and IPT technologies devices out there. You can go look to their website, just type in Intel IPT and you can see all the platforms that are out there. It's a very broad array of platforms, tablets, desktops, laptops, ultrabooks, etc., and provides a core capability in the platform for trust execution. It's been on the Intel platforms pretty broadly for about 15 months now. So how should you think of using this platform? So we're going to build a modern transaction network in Bitcoin, right? That's the goal. We're going to modernize commerce, how we interact with people, how we do business, how we execute contracts, how we move property, how we trade gold. Cool. So let's make sure that as a foundation, we have something that starts at a higher level of capability than your existing MagStripe card. So what you need is a proper payment terminal in the box. You need the concepts of a virtual set-top box or a game console. We're here at a game conference. You know, where are the tools that I have within my game console for different aspects of distribution? I need really good identity. Excuse me. We've all talked about know your customer. Well, so where's my smart card-based, nationally issued identity card credential, if that's what I want? That's maybe just the only one I've gotten. You want it in the concept and grade. I'm not so sure we want national ID cards. I want my own personal ID card. I just want it fabricated in the same way that if the government decided to issue me a card, it would have the same capabilities. It would have proper protection. It would have PIN numbers to verify it. It could be a credential that I have by myself. So we want to take all those capabilities and we want to press them into the devices we choose to use to do Bitcoin, from the manufacturer we choose to use them from. So there are two fundamental roles this technology plays to make this work. One is preventing theft of an account. How do I build a device that is tamper-proof to malware? The goal should be a very simple goal. Here's my laptop. You pick whichever core developers you'd like to have. I'll give it to them for a day. They're just not allowed to open the case. After that, I'll go execute a Bitcoin transaction and show you that I can execute that Bitcoin transaction and they can't steal my money. And I believe that is absolutely possible today on both Android and Intel platforms, leveraging these technologies. The goal is that it's a software tamper-proof environment, isolated from the operating system, really strong user-to-device binding. I will not be able to steal your PIN number with a piece of malware, and multiple layers of security to help accomplish that. Secure display is a very powerful capability to assure that the PIN number type in is the PIN number you want. The second is preventing loss of the account. In reality, we don't lose Bitcoin to malware nearly as much as I'm sure we're losing wallets on a regular basis. You know, you make a wallet, you weren't paying attention to what you're doing, and ta-da, you forgot your password. So how are we going to help that? Because, you know, humans really aren't very good at this. Like, here's your 32-character password. By the way, change it once a week and use a different one for every wallet you have. Yeah, you're done. So, because we're going to need at least, like, what, a dozen wallets, so that's a dozen 32-character passwords. Oh, there's like 4 people in the room who could actually do that. The rest of us, we need help. So what are we going to do? I think we should engage robots to help us. Automation is great. We can go to tech conferences here all about the future of automation and robotics. That's what we need. In this context, our robot's only about this big. It can be your smartphone. It can be your PC. It's the thing to help you manage this complexity of all this stuff. So a simple path is, let's just put our password, at least our private key, across our collection of devices. So if I have 4 or 5 devices, I can put the same private key on all 4 or 5 devices. I lose one, I can reach out and kill that one. Or maybe I buy a new device. Excellent. Now I get a new device. How do I put all the keys that I have on that new device in a single transaction? And so that's part of, I think, the really important piece here is how do we help that process? And we will always have to have some type of a cold storage model, a business process model to recover keys, because you never know, your house might burn down. And you know, you left your desktop, your laptop, your tablet, and your phone while you ran out the door, hopefully with the kids. Because you really should take the kids and leave the stuff behind. Some people might leave the kids behind, but at the end of the day, we need a mechanism to recover the foundations of our security so that you're comfortable in this. And I think that gets close to a model that we can help to teach others how to use this without having to train them on security. That's really the goal. So we'd like to enable this capability by provisioning the trusted computing, turning it on. My companies come from a team that has expertise in trusted computing, and bring this to the Bitcoin space and scale, helping users to manage their collection of devices, providing the first peer-to-peer attestation network so that all of these devices can check all these other devices. We talked about alternate coin models from a funding perspective. We've had great conversations with David Johnston at BitAngels about how would we leverage that to provide a mechanism where you might contribute your device to validate other people's devices. And so you can imagine a world with 1 million devices that as that whole device network comes up, it consistently is verifying all of its peers that they're feeling okay. And you're verifying that the right software is running in the right endpoints. In the end, it should be possible to actually execute events on these endpoints. And so the ability to process code within this trusted execution environment that is on a completely distributed application basis, I think is a long-term goal here that is really interesting, really exciting, because we haven't been able to do that before. We've only been able to process things that we don't care about. SETI is a good example. We don't care if the peer makes poor execution of the code. Once you turn on trusted execution, we should have distributed execution, and you truly will be able to build a billion customer parallel computer. I put a couple notes down just in casual gaming. I don't know if anybody's here actually from the game space, but this is really a very cool interaction because I can do in-game transactions with microtransactions, secure processing of critical functions, secure input. Very hard to do secure input in massively multiplayer role-playing games today. People cheat. They build programs to play the game. That's a whole different context. How do we assure that a human's playing? Store the concept of a global fact. Who's got the highest score this week? So just some thoughts on where we're headed. This is how we sort of see the technology emerging. These timescales will change as we get into the technology, but this is a general set of capabilities. By the end of this summer, we expect to have hardware capabilities that run within your platform. And we'd like to begin to show the attestation capabilities by the end of the year. I like the idea of machines with an economic identity. The idea that your device can spend your money is really kind of fun. And so I'll finish with this. This is the bringing together of two global systems. Trusted computing has had $4 or $5 billion worth of aggregate investment by the industry to build the hardware that Bitcoin needs. It's time to use it. It's one of the greatest opportunities for us to leverage a killer app of Bitcoin for trusted computing and a killer app of trusted computing for Bitcoin. These are two ecosystems that need each other. They traveled here through different paths, but now that they're finally in the same space at the same time, this is a tremendous opportunity. Trusted computing brings the customer interface to the blockchain. It's the one thing that's really hard today, and this is what makes it easy. And so we've started a company to go make that possible and to help introduce those capabilities into the broader platform. With that, thank you.
Any questions?
Hi, Jason Maurice, Wiz Technologies. I had a question about how do you monetize your technology? Are you going to be licensing it to OEM manufacturers, or are you going to be offering, maybe charging a fee for your attestation services?
So clearly, attestation services could carry a fee-based model, probably a coin-based fee-based model, which I think is interesting. In the earliest stages, I think there's an opportunity for a very simple premium wallet. It'll probably go away over time, but I think in the early start, the idea that you might spend a fraction of, think of it as $5 or $10 worth of Bitcoin to turn on the hardware security you already have in your platform as a classic application download, I think is a comfortable economic model for the user and for the ecosystem. And we would then partner with the wallet vendors to retail that. So it's an opportunity for the wallet vendors to make a little revenue as well.
I was just curious about the numbers, the growth rate, basically, because you were mentioning 200 million and 250 million for the two different platforms. I was just wondering how many new ones are coming in and the growth rate of that industry.
General rough estimates are you'll see about 350 million PCs with this capability shipped in calendar year 2015. Android, it depends on which manufacturers adopt. So Samsung's put it in everything. Quite a few of the foreign smartphone manufacturers have put it in as well. And so that's what's driving the volumes there. So it's been about 200 million a year. They've had about a year's worth of deployment. We expect that number to go up. There's really no reason it doesn't belong in every phone. And I think it really, at the end of the day, is an application-driven model, right? The manufacturer can push a button and turn on this capability in their phone. The revenue model for that industry is not a licensing model from the phone guys. It is an apps-based model in its distribution. And so we really would fully expect that you would see this reach a point of 100% saturation in the Android space. It is, both of these technologies are available to Apple. You've got Intel chipsets running in all your Mac platforms, and you certainly have ARM chipsets running all your Apple phones, and so it is an available technology to Apple. So far, they've chosen to leave it switched off. I think, again, This is an ecosystem that's being used by enterprise, is being used by government for a variety of different purposes to secure their endpoints. That's putting a huge amount of pressure on Apple. So it doesn't have to be just Bitcoin pushing them to turn it on.
You said that the user can change computer, yes, download again the software. Isn't that a key point where it could be some problem stealing my password as user for downloading the, or how do you?
So sure, I mean, realistically, this is a very simple model you're quite familiar with, which is I have a PIN number to unlock my device. You could have the same PIN on every one of your devices or different ones. Then the question is, how do my devices securely talk to each other? And so you need a one-time registration process. And in reality, you and I could exchange a code, and we could go to different ends of the world and have an incredibly secure conversation. The beauty of this is because it's one-time registration, we don't have humans trying to remember them. It's kind of like we were to introduce our two phones to each other and they swapped the keys. Really, really hard to steal that cryptographic channel. So yes, there's always a vulnerability when you can introduce something else that will share, but then it's about providing the user with awareness that, you know, any one of the devices can say, I'm connected to 3 other devices, here's their list of them. And if you see a device that you don't recognize, that's probably a bad thing.
Time for one last question.
One of the reasons why people use Bitcoin is because they want to stay anonymous. Can I stay anonymous if my hardware contains this chip with private key, or do I need to use second computer for anonymous operation?
I think this is the only way you can actually achieve anonymity really truly in blockchain. This is an opportunity for both very fast automation and creation of multiple private keys. This is where you endpoint your Tor network in a manner where software can't steal your Tor identity. So if you really truly believe in anonymity and you want to have anonymity, then I believe trusted computing is one of your only paths. Let me give you an example. Everybody today logs into a Wi-Fi network, does it through a channel where they have some authentication credential, etc., and they expose their MAC address, which is in and of itself a problem. But let's assume we can alter the MAC address on a regular basis. So I have that authentication to network because somehow I checked into this hotel and therefore I have access to Wi-Fi. In lots of cases they type your room number in. What trusted computing makes possible is that I could have, for example, an AT&T Wi-Fi connection where instead of a unique AT&T identifier, I purchase the March key. And that would give you the equivalent of a cash-paid phone. So what you have then is everybody sharing the same credential, which is the March credential. And so I just know that you're one of the 500,000 people that bought the March credential for Wi-Fi. And so if I capture your platform, I can find out that you had a March Wi-Fi key and somebody with a March Wi-Fi key did something bad. But I have very hard time the other way around, which is if I just have the network information, I have no idea who was on the network. It's very much similar to the model of buying a cash phone. I took cash as my transaction and I bought a phone that doesn't have any identity because I used cash for the purchase of the phone. And I think those are the models that actually give you really true anonymity. And so that's one of the challenges in this space. I think trusted computing is agnostic to privacy or really strong identity. The technology can be used for both, and you can do both at the same time, really strong identity and anonymity, same platform.
Thank you, Stephen.
Thank you.